In part 2 of section 2.5, we are going to talk about how to stretch and shrink a graph, how to combine transformations together, and how to work backwards by writing equations. So the rule for identifying a vertical stretch and shrink. Y equals c times f of x, so a constant multiplied by the function f of x, will be the graph of f of x, vertically stretched by multiplying its y coordinates by c if c is larger than 1, and it will be vertically shrunk by multiplying its y coordinates by c if c is between 0 and 1. So if it's a fraction, a positive fraction less than 1. To apply a vertical stretch or shrink, you multiply the y values by c. We just call it a stretch if the c is larger than 1, and we call it a shrink if the c is between 0 and 1. So our two examples here are for two of our common functions. The first one we're going to look at f of x equals 1/3 times x squared. So this would be the common function y equals x squared, which is the u shape. The transformation would be a vertical shrink by the factor of 1/3. We call it a shrink because this number is between 0 and 1. So we're going to take the original graph x squared, which is shown here by the dotted curve, so negative 1, 1, 0, 0, and 1, 1. And we're going to take all of the y coordinates and multiply them by 1/3. So the y coordinate right here is 1. 1 times 1/3 is now 1/3. So that one moves down here to being 1/3. 0, 0. So y value of 0 times 1/3, it's still 0, so it stays where it is. And then this y value of 1, 1 times 1/3 moves to 1/3. So the x's don't change. We just multiply y values by 1/3, and notice we get this still a U-shaped graph, but notice it's closer to the x-axis. That's why it's called a shrink. In our second example, g of x equals 2 times the cubed root of x. So this time our common function is y equals the cubed root of x, which is the horizontal S-curve that looks like this. The transformation is going to be a vertical stretch. We call it a stretch because the value of c is larger than 1, so we're going to do a vertical stretch by the factor of 2. So the y values of this graph are going to get multiplied by a 2. So the dotted curve is the original. So this point right here has a y value of negative 1. When I multiply that by a 2, it's now a negative 2, so that point moves down here. 0 times 2 is still 0, so that point stays where it was. And then the other point, the y value of 1, multiply the 1 by a 2, now it becomes a y value of 2. So we get this new graph. We call it a stretch because notice the graph is now further away from the x-axis than it was before. So now we're going to look at combining the transformations together when you have several of them at once. Use the given graph of f of x to graph the new function y equals negative 2 times f of x plus 1 minus 1. So we're going to use this given graph of f. So this is f of x. This would identify our transformations. So notice on the inside we're adding 1, so that's adding on the inside is going to be a horizontal shift left 1. Outside here we've got a negative and a 2, so the negative is going to cause a reflection in the x-axis. Then the 2 is going to cause a vertical stretch by a factor of 2. And then finally, back here at the end, we have minus 1. That's going to be a vertical shift down 1. When you have all four types of transformations, this is the order in which they need to be applied. Horizontal shifts are identified first, then any type of reflection happens second, any stretches or shrinks happen third, and then vertical shifts always happen last. So on this one, I'm going to draw a graph for each one of these individually. When you're doing these in MyMathLab, you just have to indicate what's going to happen, and it will automatically apply those for you where you don't have to do them one at a time, or it'll be a multiple choice. You just choose the right graph that ends up in the right place. All right, so our first transformation is to move left 1. So if I'm taking this graph and moving everything left 1, this point right here is at the x value -2. It's going to shift left 1 and become the x value at -3 right here. This one's going to go left 1 and land at -2 right here. The origin is going to move left 1 and land here at -1. This point moves left 1 and lands at x equals 0, y equals 1, and then this point moves left 1 and lands at the 1, 1. So that's what we get if we shifted it left 1. Second, we're going to reflect in the x-axis, and then we go from where we ended on the previous step. So this is the graph that gets reflected. So flipping this upside down. So this little line segment, these 2 points are going to flip across the x-axis and move up here. This is going to stay where it's at, and then this little piece here is going to flip down below and end down here. So it's going to end up across, straight down, and then over. So you can do point by point, flipping it across the x-axis, or you can kind of go piece by piece, but this is where we end up when we reflect that across the x-axis. Next is the vertical stretch by a factor of 2. So from the previous step, this would mean all the y values get multiplied by a 2. So right along this little piece, the y value is 1. So when I multiply that by a 2, it's going to move up here to this little segment being at y equals 2. Here it hits the origin. When I multiply 0 by 2, it stays 0, so that point doesn't change. And then this little piece down here, both of these points have a y value of -1. So when I multiply that by a 2, it becomes a -2. So that stretches down here. So you end up with this line segment up here across here at y equals 2, and then this vertical line down through that same point at the 0, and then across down here at -2. And then finally, our last transformation for this problem would be moving it down 1. So this graph, every point gets shifted down 1. So this little segment is up here at y equals 2. It's going to shift down here and end up at y equals 1. This point we're going to pick up and move down to here. And then this little line segment, we're going to do the same. And it was at -2 before. It's going to move down 1 and land at -3. So everything got moved down 1 to produce this final result. And then our last example is working backwards. This one says write an equation for the graph shown. The graph shown is the one in black right here. So we're starting here at 2, 2, and then we're curving in one direction downward with this shape. So we can identify the shape of the graph as being the same general shape as the square root function. So if I kind of draw in this little dotted curve as what the square root of x would have looked like to begin with, and then we're going to figure out how to move this dotted curve to end up where this one landed. So it got shifted over to the right 2. So I'm just writing down what I notice is happening here to this dotted curve. So if I shift it to the right 2, it would land right here. It is upside down. So if this curve that was here got reflected over the x-axis, it would come down this way. So that's my reflection in the x-axis. And then otherwise, it just got picked up and moved up 2 spots from there. That's still upside down. So we would have started with this, moved it right 2, reflected it across the x-axis, and then moved it up 2. So I'm going to fill in my equation to reflect these transformations. So the square root shape, right 2 would mean subtract 2 on the inside. That would move horizontally to the right 2. Reflecting the x-axis puts a negative on the outside. And then moving up 2 puts a +2 at the end. So that is the end of section 2.5.